All right, in today's lesson, we are looking at polynomial graphs, and we're going to use graphing calculators and Desmos to help us get these graphs. But the idea is, just by looking at an equation, can we get a basic understanding of a few things before we use technology to help us graph? So, let's look at an example. So the first one, f of x equals 3x to the fourth minus 5x squared minus 1. So n is even, that's your exponent. A is positive, that's your leading coefficient. So those two things should tell us some information. What I'm going to do is just draw a horizontal line to kind of mimic the x-axis. If I have even exponent, positive coefficient, I know the end behavior is going to be like this. And then in between, I could have all kinds of stuff going on. But I know the end behavior. So the idea is if I have a fourth degree, what that means is I know I'm going to have a graph like this. It's going to touch the x-axis a maximum of 4 times. It can't touch it more than 4 times. It can touch it less than 4 times. But here would be an example of, okay, it crosses once, it has a turning point, crosses a second time, has a turning point, crosses a third time, crosses that fourth time. So it turned 1, 2, 3 times, and it crosses 4 times. What that is a maximum amount of turning points and x-intercepts. It might not have that many, but it can have more than that. And before I even start graphing, I know just by looking at the leading term that it's supposed to be infinity. As x approaches infinity, y will approach infinity. And as x approaches negative infinity, y will approach positive infinity. That both going towards positive infinity. So now, if we use graphing calculator or Desmos, we can get some points. So here's what the graph actually looks like. And on these graphs, each unit will be 0.5. So like this will be -1, +1. So lots of decimals, but we're just getting a sketch. So I'm going to have point here. Just kind of looking for about some key points. So it does this. So it could cross the x-axis a maximum of 4 times. Here it only crossed twice. And it can have a minimum of 3 turning points. In this case, or a maximum of 3 turning points. So there's 1, 2, 3. Awesome. Okay, let's look at another example. G of x equals -2 x to the 6th plus 4x to the 4th plus 2x squared. So I still have an even exponent, but my a is negative. So before you graph anything, I know that this negative coefficient is going to flip my graph, but because it's an even exponent, they'll be ending in the same direction. So there might be all kinds of things that happens up here, but I know that end behavior will be pointing down in the same direction. So once again, I'm going to just draw a horizontal line to represent a hypothetical x-axis. So in this case, because the exponent is 6, let's see, I'm going to start down. That means I can cross 1, turn, 2, turn, 3, turn, 4, turn, 6, goes down. Now, it might not actually cross the x-axis 6 times, but in this case, there's a maximum amount that it could. It can't be more than 6. It could be 6 or less than 6. And then turning points, 1, 2, 3, 4, 5, a maximum of 5. Could be less, can't be more. Okay, so if we graph this, it actually, and once again, I'm counting by 0.5 units, and we're just getting sketches, just trying to get an idea of what these graphs can look like. I'm going to go over, looks like 1, 2, just a little bit here. It's not exactly at an integer, but it's close. And then off the graph a little bit here, just kind of looking for some key points. And what happens is it's going to go up, it's going to go down, it's going to go up, it's going to go down, like that. Okay, continuing this idea, but now we're switching to odd exponents. So h of x equals x to the third minus 2x squared. Okay, so I've got an odd exponent in a, my coefficient is positive, it's just positive 1. Same idea, I'm going to draw hypothetical x-axis. So 3, which means it could cross a maximum of 3 times. And let's see, end behavior, it would be down in one direction, up in the other direction. And then, you know, lots can happen in between. So I know the end behavior, and it could cross a maximum of 3 times. 1, turn, 2, 3. So it might cross less than 3, can't cross more than 3, and then 2 turning points. Okay, when you graph this, still counting by 0.5, and we are just looking for key points, totally estimating. It's about 2.5 or 1.5 if I'm counting by 0.5, I guess. So in this case, it's going to go up, down, and up. So as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. And you should be able to answer this question without looking at the graph, just by looking at the equation and that leading term. All right, last example. F of x equals negative 4x to the fifth minus 8x to the third plus 2x. All right, odd exponent, a negative coefficient. So this time, the directions are going to be like this, of the end behavior. And then there can be a lot that happens in between. Hypothetical x-axis, I'm going to start, end in these directions. If the exponent is 5, I could cross a maximum of 5 times. 1, 2, 3, 4, 5. And then it would have 1, 2, 3, 4 turning points. Maximum value is not guaranteed that you'll actually have that many. So without even graphing, as x approaches infinity, y is going to approach negative infinity. And as x approaches negative infinity, y will approach positive infinity. Okay, so now if we graph, I'm going to get some key points. They're kind of close together here because it kind of goes down, up. This goes up. Whoops, I just erased it. Down like that. All right, so once again, can you look at the leading term and just know a lot of information? But then we're going to use Desmos and graphing calculators to get our sketches of our graphs. Okay, so we've already talked about this. I'm going to give an example. Negative 2x to the 7th plus 4x to the 4th minus 3x squared. So can we answer these questions by simply looking right there? So end behavior, how many real zeros and how many turning points at most, meaning maximum amount. So let's look at, I think these are sometimes the easiest. So how many real zeros? Well, it's just the same number as your degree, 7. So this has a maximum of 7 zeros. Could have less, can't have more. Okay, turning points, it's your degree minus 1. So this means it has a maximum of 6 turning points. And then you should be able to know a general sketch of the end behavior. So it's an odd exponent and it's negative. So it's going to do this. As x approaches infinity, y will approach negative infinity. As x approaches negative infinity, y will approach positive infinity. All right, last example without looking at a graph. 3x to the 4th minus 4x to the 3rd plus 8. Look here, even exponent, positive here. And degree 4, so degree 4 means there's a maximum of 4 zeros. And there's a maximum, one less than 4, of 3 turning points. And I know that the graph end behavior, they're both going to be pointing up. So as x approaches infinity, y will approach positive infinity. And as x approaches, negative infinity, yeah, y will approach positive infinity. So there is your full video on polynomial graphs to see what can you determine just by looking at the leading term. All right, good luck with your lesson.